we're going to simply look at what's called an ordinary annuity. We're going to look at a stream of cash flows where all the payments are equal. We're going to solve for the value of an annuity. This is called an ordinary annuity. This is a technical term for it. It doesn't mean an everyday annuity. It means an annuity which works in the ordinary fashion, where the payments are happening at the end of each period. In your financial calculator, you can take 4 inputs and solve for the 5th one. So you can find the present value given N, I, PMT, and FV. You can find the future value given N, I, PMT, and PV. Now, frequently in your book, you're going to find problems where you have to make an assumption about the PV or the FV, whichever one you don't know. You might have to assume, for example, that the future value of something is 0. In the magic machine example, when I explained that, I specifically said that the machine vanished at the end of its function. It spat out that last $100 bill, and then it vanished in a puff of magical smoke. The reason I did this was to make sure that there was no residual value, no salvage value that it could be sold for, no additional disposal costs or anything like that. It was just the cash flows. It was just the annuity itself. So what we'd be putting into our calculator would be N equals 60, because there were 60 monthly payments. We'd use an interest rate of 12 divided by 12. Now, 12 divided by 12 is 1%, but as I said before, if we've got a number which doesn't come out even or has a long string of digits or a repeated digit, like that 12% divided by 360 days, then it's better to get into the habit of using the fraction. So when you put these numbers into your calculator, I want you to learn to do this by using the fraction method. So put in 12 divided by 12 just to build the habit for yourself. The payment was $100 per month. It was an inflow. We'll also leave that as a positive number. And the future value is going to be 0. In other words, this thing has no value once the payment is delivered. I'm going to get into the calculator functions separately. There is on my website a sheet called How Do I Use This Financial Calculator, and that is a document that I'm going to be referring to while we talk about that. So we'll get to that point in a few minutes. But for right now, if we were to plug this into our financial calculator, we would come up with the same answer that we did before. There's another type of annuity that we need to be aware of. There's something called an annuity due. An annuity due is an annuity in which the payments happen at the beginning instead of the end of each time period. These are frequently used in real estate. If you want to be the next Donald Trump, you should be very, very familiar with annuities due. If you are a finance student at a university, you need to be very, very careful because your calculator has a different setting for annuities due. And for most of them, it's a very, very subtle setting. And it will change the value of the computations that you're making without much warning. If you were looking at a timeline with an annuity due, let's say a 10-year timeline like I had drawn up in one of the earlier slides, it could be that you're going to have nothing underneath the 0 period, and you'd have an identical payment underneath 1, 2, 3, 4, etc., 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 all the way out to the 10th. But what happens if we move those up to the beginning of each period instead of the end? Instead of that last payment happening at the end of the 10th period, it would happen at the beginning of the 10th period. Now, the beginning of the 10th period, if you think about it, is actually the end of the 9th period. So we're really just going to move every cash flow one stop to the left. And that means that that first cash flow moves from being underneath the 1 to being underneath the 0. So we could rediscount the last cash flow and the first cash flow in order to come up with what our different value is. All of the rest of them are really staying the same. Or we could simply change our calculator setting to have the annuity due, and it would give us a slightly different answer. The advice that I have for you about the calculators is this. As soon as you're done with an annuity due problem, reset your calculator immediately. Good habits with the calculator will help you avoid mistakes later. Another topic, which is something which is going to build into material for the rest of the quarter, is this idea. What happens if we have an ordinary annuity which also has an additional payment? In other words, if we were to use the example of the magic machine, we might still have a $100 payment which is happening at the end of every month for 60 months. We'd have a 5-year period of time paying out $100 a month every month. Plus, let's say we could then sell that machine for scrap. What if we could get $1,000 worth of scrap value from the machine after it had made that last payout? Really then we've got two business propositions. We've got the machine which produces the $100 repeated cash flow to us. And then we've got a second proposition which is the value of $1,000 which we can only capture at the end of that 5-year period. So we've got two different computations. One way to do that is to figure out the value of the annuity, the value of that $100 for 60 months at the appropriate rate of return, and then figure out the value of that $1,000 future value discounted by 60 periods. And then we take the value of the annuity and we take the value of that single cash flow, and we can add those two values together to get the value of the total proposition. Work that out on a piece of paper. And then when you're done, write down the inputs to put into your financial calculator, which would be to find the present value given n equals 60, I equals whatever your appropriate interest rate is, your payment equal to $100, and your future value equal to $1,000. What you should get as a result of finding the present value on your calculator with those inputs is an answer which is equal to the sum of those two different cash flow streams that I talked about before. It should be the sum of the annuity plus the sum of that single cash flow, that $1,000 single cash flow. When you add those together, you're going to find there's a little bit of a discrepancy, a few pennies probably, and that's the result of rounding. When you had your answers, there were a few digits that weren't shown on your calculator that are going to be carried forward.